Hello, this is Colton Ritter. I'm going over my PowerPoint over Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol, or DHCP, is a network management protocol used on UDP/IP networks whereby a DHCP server dynamically assigns an IP address and other network configuration parameters to each device on a network so they can communicate with other IP networks. A DHCP server enables computers to request IP addresses and networking parameters automatically from the Internet Service Provider, or ISP, reducing the need for a network administrator or a user to manually assign IP addresses to all network devices. DHCP can be implemented on networks ranging in size from home networks to large campus networks and regional Internet Service Provider networks. A router or residential gateway can be enabled to act as a DHCP server. Most residential network routers receive a globally unique IP address within the ISP network. Within a local network, a DHCP server assigns a local IP address to each device connected to the network. UDP/IP defines how devices on one network communicate with devices on another network, and the DHCP server can manage UDP/IP settings for devices on a network by automatically or dynamically assigning IP addresses to the devices. The DHCP operates based on the client-server model. When a computer or other device connects to a network, the DHCP client-server software sends a DHCP broadcast query requesting the necessary information. Any DHCP server on the network may service the request. The DHCP server manages a pool of IP addresses and information about client configuration parameters such as default gateway, domain name servers, and time servers. On receiving a DHCP request, the DHCP server may respond with specific information for each client as previously configured by an administrator, or with a specific address and any other information valid for the entire network and for the time period for which the allocation is valid. A DHCP client typically queries for this information immediately after booting, and periodically thereafter before the expiration of the information. When a DHCP client refreshes an assignment, it initially requests the same parameter values, but the DHCP server may assign a new address based on the assignment policies set by administrators. On large networks that consist of multiple links, a single DHCP server may service the entire network, and then, when aided by DHCP relay agents located on the interconnecting routers. This is an example of DHCP. Agents relay messages between DHCP clients and DHCP servers located on different subnets. Dynamic allocation. A network administrator reserves a range of IP addresses for DHCP, and each DHCP client on the LAN is configured to request an IP address from the DHCP server during network initialization. The request and grant process uses a lease concept with a controllable time period, allowing the DHCP server to reclaim and then reallocate IP addresses that are not renewed. Automatic allocation. The DHCP server permanently assigns an IP address to a requesting client from the range defined by the administrator. This is like the dynamic allocation, but the DHCP server keeps a table of past IP address assignments so that it can assign to a client the same IP address that the client previously had. Manual allocation or static allocation. The DHCP server issues a private IP address dependent upon each client's client ID, or traditionally the client MAC address. Based on a predefined mapping by the administrator, this feature is variously called static DHCP assignment by DDWRT, fixed address by the DHCPD documentation, address reservation by Netgear, DHCP reservation or static DHCP by Cisco and Linksy, and IP address reservation for MAC/IP address binding by various other router manufacturers. This is an overview of DHCP operation. DHCP operations fall into 4 phases: server discovery, IP lease offer, IP lease request, and IP lease acknowledgement. These stages are often abbreviated as DORA for discovery, offer, request, and acknowledgement. Operation continued. The DHCP operation begins with clients broadcasting a request. If the client and server are on different subnets, a DHCP helper or DHCP relay agent may be used. Clients requesting renewal of an existing lease may communicate directly via UDP unicast, since the client already has established an IP address at that point. DHCP relaying. In small networks where only one IP subnet is being managed, DHCP clients communicate directly with DHCP servers. However, DHCP servers can also provide IP addresses for multiple subnets. In this case, a DHCP client that has not yet acquired an IP address cannot communicate directly with the DHCP server using IP routing, because it does not have a routable IP address, does not know the link layer address of the router, and does not know the IP address of the DHCP server. Reliability. The DHCP ensures reliability in several ways: periodic renewal, rebinding, and failover. DHCP clients are allocated leases that last for some period of time. Clients begin to attempt to renew their leases once half of the lease interval has expired. They do this by sending a unicast DHCP request message to the DHCP server that granted the original lease. If that server is down or unreachable, it will fail to respond to the DHCP request. Security. The base DHCP does not include any mechanism for authentication. Because of this, it is vulnerable to a variety of attacks. These attacks fall into 3 main categories: unauthorized DHCP servers providing false information to clients, unauthorized clients gaining access to resources, resource exhaustion attacks from malicious DHCP clients. Security continued. Because the client has no way to validate the identity of a DHCP server, unauthorized DHCP servers, commonly called rogue DHCP, can be operated on networks, providing incorrect information to DHCP clients. This can serve either as a denial of service attack, preventing the client from gaining access to network connectivity, or as a man-in-the-middle attack, because the DHCP server provides the DHCP client with server IP addresses, such as the IP addresses of one or more DNS servers. An attacker can convince a DHCP client to do its DNS lookups through its own DNS server and can therefore provide its own answers to DNS queries from the client. This concludes my PowerPoint over DHCP.